on the differences between qualitative and quantitative data. Qualitative data, part 1. So qualitative data is descriptive or conceptual data. It's data that you can basically provide a description of. So for instance, we have a photo here. This is in a tent. This was with a group of students that I had a little while ago, and we were in a tent and we were simulating an exercise where we were pretending to be refugees, and we were conducting an interview. And an interview is something that is descriptive. It's not something which has a lot of statistical or numerical availability to it. It's something which is an example of qualitative data. Qualitative data can be categorized based on identifiers. So I can say that there is an interview, and that I can conduct a series of interviews based upon, for example, refugees, and these will all be identified as refugee interviews. That's a fairly weak qualification of what makes qualitative data, but qualitative data by its nature is unorganized, difficult to put into boxes. Qualitative data is also very rich. What I mean by rich is that it has a lot of different qualities to it, which again make it difficult to categorize in any meaningful way. So for instance, in this particular interview, if I'm filming it, I will have lots of different types of data. I will have the text from the interview itself. I will have the qualities of the person that I'm interviewing. I will have the scenario that I'm interviewing. I'll have the recording equipment that I used. I will have the weather at the time. All these parts constitute the qualitative data in some respect. Some are more important than others, and it's your responsibility to basically consider which variables of this are the most important. The other important concept with qualitative data is it often veers off into things that you're not necessarily concerned with. So for instance, in this example with refugees, if I'm looking to build a borehole, for instance, so they can get water, and they're not talking about boreholes anymore, they're talking about something else. So for instance, they're hungry, or they're looking for something to do, or they're gossiping to me about something in particular. That isn't a part of the information I'm looking for, but it still might be important, valuable information in the right context. That's what I mean to say that qualitative data is rich. There's all this information, and going through it and taking what you need out of it can sometimes be challenging. So a little bit more explanation on what qualitative data includes. So these are just a few examples of what qualitative data can take the form of. Transcripts from interviews is a very good example, as we just discussed. Pictures or photographs. If you have to describe a photo or a picture, just think of the picture that you've recently taken on your smartphone. You can't really provide numerical information on that. I mean, you could, but it wouldn't be meaningful in any way. Like, you could say it has this amount of pixels in it, which are represented as white, but that doesn't really tell the story of why you took that picture. What you're wanting to say is, it's a picture of a friend, it's a picture of some food, it's a picture of whatever else it might be, and that informs us about why the picture was taken, what's important about the picture. Qualitative data can include a description of something. So for instance, if I have, and this is an example I saw in the notes that I'll provide, I saw a chest of drawers. If I say that chest of drawers is brown and it has a nice finish and it has some scuff marks and it has 3 doors, but one of the drawers doesn't work, that is an example of qualitative data as well. Some types of statistical data can be qualitative. It's any ordinal or nominal data is considered qualitative. Ordinal data refers to anything where you can say that something is greater than something else, but the magnitude of how greater that thing is isn't discussed. So, for instance, for my personal thing, let's say that I like eating chocolate and I also like eating toast. And I say that I prefer eating chocolate over eating toast, and I like eating both of those more than Brussels sprouts, let's say. Brussels sprouts are disgusting. That's ordinal data because one is greater to me than the others. However, I can't really put a specific number as to how much greater one of these things would be compared to the others. There's also nominal data, and nominal data is basically anything which is an identifier. So if you had, for example, in your projects, you'll be looking at particular streets around your neighborhood. A street name, for instance, that is an example of nominal data because there's no number assigned to it, it's just a categorization. Quantitative data is different. Quantitative data is structured and it's defined. It's well defined, it's well organized. The figure here is a pretty standard example of what quantitative data might look like because this information is very well classified, and there's numbers associated with it. Quantitative data is usually discrete. That is to say that it has factors which can't be broken down any further, or if you do break it down, then it's meaningless. Quantitative data has data points, so these graphs here represent specific data points, and these represent the measure of a single variable. In this example, for example, here we have zinc, and zinc changes its solubility as it changes its pH, and this is a single variable for a single function. So, quantitative data part 2. Quantitative data often includes experimental measurements, for example, the pH level of a solution or the measure of chemical abundance. If you run something that can calculate, for example, the amount of iron in a particular compound. It can include things like survey questions, but this would be something like, on a scale from 1 to 5, with 5 being most likely and 1 being not likely at all, how likely are you to use public transport? That would be an example of quantitative data. So it's numeric, almost always in form, and it has information that has a range. Practically all metrics involve quantitative data in some way. Measurements of height, measurements of weight, heart rates, all this stuff is quantitative data. Quantitative data can be discrete, as we were talking about before, in that it can't be broken down. Quantitative data can also be continuous, and from continuous, which means that it has a range that goes on for a very essentially infinite, functionally, usually not infinite, and can be measured in interval or ratio scales. Basically, the difference between interval and ratio scales is that ratio scales, if memory serves, tends to have, let me just make sure that I've got the absolute right thing to say, because I don't want to give you a poor steer. They have things which can be broken down into exact values, and ratio scales can be divided, added, subtracted, and multiplied. So you can, for example, weight is a great example of a ratio scale. So you could say something like, if I add 4 kilos to 8 kilos, I get 12 kilos. That's what a ratio scale can do. Interval scales are very similar to that. You can measure them. Honestly, there's not a huge amount of difference between the two, but you can't multiply or divide them. So for instance, if you have temperature, you can't multiply 20 degrees by 2 and get 40 degrees. That's just not functionally accurate. Okay. Data transformation. So what sometimes you can do is transform the data from a qualitative data to quantitative. You can do this. There are ways of doing it. In order to do that, you have to justify why you're doing it, and you have to be very systematic about how you do it. One of the problems with qualitative data is that it's very easy to add in your own bias or take things out of it that you want, but that's not an accurate reflection of what is actually being observed for either an experiment or some kind of investigation that you're carrying out. So often you have to justify what you're doing and how you're doing it. And here are some additional resources. Study Online and Learn.g2 give you basic examples of what to do. If you really want to get into the differences between qualitative and quantitative data and get into even more detail regarding the type of data and manipulation, I recommend any within the series of DeVos Surveys and Social Research by Allen and Unwin, Australia. Okay, thank you.